In this video, we will study the relative motion analysis for the case of acceleration. As we know that from the velocity vector is composed of two terms. It is composed of the velocity from translation and velocity from the rotation, that is relative velocity VB sub A. Okay, so uh, the accelerations of 2 points on the body is determined by differentiating the velocity equation with respect to time. So for the first two term, that is dvb by dt and dva by dt, they are absolute acceleration of point A and B because they are measured from a set of fixed reference frame xy. Okay, but for the last term, that is dvb sub a over dt, this term is the acceleration of point B with respect to A, including both tangential and normal components. This is the term of rotation. That if we consider graphically, in this case, for body AB undergoes general plane motion. It is composed of the translation and rotation about fixed axis. That is, now we consider point A as the base point. So then is a combination of the translation, that is acceleration of point B. It is equal to acceleration of point A for translation, and it's combined with the rotation about point A, that is composed of the acceleration in tangential and normal direction. That's from we study from the case of rotation about a fixed axis. We know that the relative tangential acceleration component is alpha cross RB sub A. Okay, and it is perpendicular to RB sub A. And relative normal acceleration components is O minus omega square RB sub A. And the direction is always from point B to point A. Okay. So in conclusion, that when we would like to find the acceleration by using relative motion analysis, we will use this equation that is composed of acceleration of point A, that is due to the translation only, and combined with the relative acceleration of point B with respect to A, that is composed of the acceleration in tangential components and acceleration in normal component. And for the last term, omega square is a scalar term. That is one thing that we have to focus on this equation. Is just only this term, omega square is a scalar. Okay, and we may study this technique by following this example. Okay, point A on lot AB has the acceleration of 5 meter per second square. Okay, and a velocity of 6 meter per second as the instant show. And in both directions goes down. Okay, and we would like to find the angular acceleration of the lot and the acceleration at point B at this instant. Okay, so for this case, we may use the technique of instantaneous point of zero velocity, IC. Okay, so for this case, we know that VA is go down, okay, and VB is to the right. Okay, when we draw the line that is perpendicular to these two velocity, we can find the point instantaneous center of zero velocity, this point IC. Okay, so according to this point, we can determine omega of lot AB by using this reference point. So omega of lot AB is equal to VA. That now we already know. from the problem, it is equal to 6 meter per second. Okay, and A sub IC now is equal to 3. Okay, because of the relationship of this triangle, we already know that it should be 3. Okay, so actually I may redraw the picture like this. Okay, IC should be here. Okay, so for this case, RA sub IC is equal to 3. Okay, and now we can find omega is become 2 radian per second. Okay, 2 radian per second, and it's this counterclockwise. Okay, so because we know that AA is 5 meter per second square go down, and AB we don't know how much it is, and we know that it should be along the horizontal line. Okay, so it should have just only I components. Okay, so AA and AB we may predict that it has just only one component. For A, it just has only one component in vertical direction, and for B, it has just only one component in horizontal direction. Okay, so according to this, we apply the relative acceleration equation, and AA, and we found out AB equal to AA plus alpha cross RB sub A minus omega square RB sub A. Now we have to find RB sub A is what? So in order to find RB sub A, we set up the axis at point A because we would like to find the vector from of point B from point A. Okay, so then we set up point A as the reference. Okay, so according to this, we found that RB sub A is become 3I minus 4J. Okay, and alpha we don't know now. Okay, but we assume it to be the positive side, positive direction first. That is, now we assume it to be positive in K direction. And for the case of omega we already know from the previous slide that we know that omega AB is become 2. Okay, and RB sub A we already know, right? Okay, so according to this, after we solving this term, that is the cross product, okay, we already have this equation. From this equation, we can rearrange this equation, and by comparing the I and J components, we will get two equations like this. And after that, we can solve for the unknown. That is A, B is equal to minus 26.7 meter per second square. Okay, the minus sign is mean that it should go to the left. Okay, and alpha is minus 3.67 radian per second square. It should be clockwise. Okay, let's complete this problem.